So let's get right into it. We hear about these huge cyber attacks all the time, right? But have you ever wondered why they're so ridiculously hard to stop? I mean, it's not like there's just a big block button someone can press. Today, we're going to break down how these modern attacks actually work, and you'll see why the old ways of defending ourselves just don't cut it anymore.
Just think about it in your own life for a second. We've all done it, right? You block some annoying account on social media, or you block a spam email address. It's super simple. You see the problem, you block the source, and poof, problem solved.
And for the longest time, that's pretty much how cybersecurity worked too. An attack would come from one specific server, a single IP address. The logic was super simple, and honestly, it was pretty effective. I mean, look how clean this process was. Step 1, you spot the bad guy's IP address. Step 2, you just put up a digital wall to block that one single source. And step 3, the attack is over, threat neutralized. It was kind of like a bouncer at a club just tossing out one person who's causing trouble. Okay, but this is where that whole simple model just completely falls apart. What happens when it's not just one person trying to crash the party? What if it's an entire city showing up at the door all at once? And this really puts it into perspective. On one side, you've got your single attacker. Yeah, easy to see, simple to block. But on the other side, you're dealing with a swarm of 100,000. There's no way to identify all of them, and you for sure can't block them one by one. The game has totally changed.
100,000. Just let that number sink in for a minute. Trying to block each one of those individually would be like trying to catch every single raindrop in a hurricane using a coffee cup. It's just not possible.
And this brings us to a really stark conclusion. When you're dealing with that kind of scale, the very idea of blocking just stops working. It's ineffective. The old playbook, it's officially useless. So, how in the world do attackers pull off something this huge?
Well, they use something called a botnet. And what that is, it's basically a hidden army. But it's an army made up of everyday devices you and I use. Infected computers, security cameras, maybe even your smart toaster. Seriously. And all of them are controlled by a single person, ready to launch an attack at a moment's notice.
This is where the strategy gets really genius and, frankly, pretty terrifying. Because this isn't an army that you can see marching over a hill. Nope, this army is already inside our homes and offices, and it's disguised to look just like us. Think about what this actually means. These attacks are coming from all over the planet, from real home internet connections on completely normal devices. So the traffic they generate, it looks exactly like you or me just browsing the internet. Which creates this impossible problem. How do you block an attacker who looks identical to a real customer? You know the old saying about finding a needle in a haystack? Well, that doesn't even work here. This is like trying to find one specific needle in a giant stack of other needles. You can't filter out the bad stuff without blocking tons of your actual legitimate users. Okay, so if that wasn't complicated enough, there's a whole other level to this, a much sneakier one. What if the attackers could launch a devastating attack without ever sending a single piece of data to the victim directly? This unbelievably clever method is called a reflection attack, and it's all about turning the normal, everyday infrastructure of the internet into a weapon against itself. So the whole thing works because of a trick called IP spoofing. Now, the simplest way to think about this is like sending a letter in the mail, but you write a fake return address on the envelope. And whose address do you write? The victims. All right, let me walk you through how this works because it's pretty wild. First, the attacker sends out thousands of tiny requests to all these public servers on the internet, servers that are designed to answer anyone. But, and this is the key, on every single one of those requests, they faked the return address. They've put the victim's IP address there instead. So what happens? All of those servers do their job and send their responses back to the address they were given. And suddenly, the victim system is just completely buried under an avalanche of data that they never asked for. What's so nasty about this is that the attacker's fingerprints are nowhere to be found. They get innocent third-party servers to do all the dirty work for them. So if you're the victim, you're not seeing some evil attacker's IP. You're just seeing thousands of perfectly legitimate servers from all over the world flooding you with traffic. How do you block that? And that brings us right back to the central theme here. It all comes down to this one idea: distribution. It doesn't matter if it's a distributed army of bots or a distributed attack reflected off of thousands of servers. The end result is the same. So what we've really seen are two main strategies. You've got the brute force method, that massive botnet swarm. And then you have the clever, deceptive method, the reflection attack. But both of them are designed to do the exact same thing, use massive scale and hide in plain sight to make those old-school defenses totally obsolete. And that leaves us with the fundamental, maybe multi-billion-dollar question facing cybersecurity today. Traditional security was always about building a bigger, stronger wall around your castle. But if the attackers can come from everywhere and anywhere and might already be inside, where do you even begin to build that wall?